Welcome to 6502 Assembly Language Programming. In this video, we'll look at shift and rotate operations. Let's look at what's different and what's similar in the shift and rotate instructions. What they have in common is that they both shift bits, either to the right or to the left. And there are variants of these instructions that can be used either on the accumulator or on an address in RAM. They only differ in what happens to the bit on the edge. That would be bit 0 or bit 7 that doesn't have a bit being shifted into it. With shift instructions, all the bits are shifted one direction or another, here to the left. The high order bit in this case is shifted into the carry flag, but a 0 is shifted into the low order bit. With the rotate instruction, the high order bit, in this case we're doing a rotate left, the high order bit is copied into the carry flag, and the carry flag is copied into the low order bit. Now, all these transfers and copies happen simultaneously, so there is no danger of the carry flag, for instance, getting written over before it's copied into the low order bit. Let's get into some specific instructions. Our first instruction is ASL, arithmetic shift left. As you can see, it shifts all the bits to the left. The high order bit is copied into the carry flag, and a 0 is copied into the low order bit. Logical shift right. You can see a 0 being shifted into the high order bit and all the bits getting shifted to the right. And the low order bit getting shifted into the carry flag. Now rotate instructions. In rotate left, all the bits go left, high order bit into the carry flag, but not before the carry flag is copied into the low order bit. Rotate right works the same except in the other direction. You can see the bits going to the right, low order bit getting copied into the carry, and the carry copied into the high order bit. Shift and rotate instructions are useful when a value is embedded in a byte. For instance, the 4-bit version number is embedded in the first byte of a TCP/IP packet. In order to extract and compare the version number, it's necessary to do the following. First, we have to shift the bits into the right position. If we use the rotate instruction to do that, then we have to isolate the required bits with an AND instruction. However, if we use the shift instruction to accomplish the shifting, then we already have 0s in the other bits and we're done. Here are the starting conditions for our exercise. We've already loaded the first byte of the TCP/IP header into the accumulator and we're ready to shift it. After performing one ASR instruction, you can see that all the bits have been shifted right, except that the high order bit has a 0 shifted into it, and the low order bit has been shifted into the carry flag. After our fourth ASR instruction, we have all the bits in the right position, and we're ready to do our compare. Now we are ready to perform our comparison, and you can see that we're doing a comparison against the immediate value 4 and branching to is version 4 on the correct version number. Let's go to the IDE and have a look at the exercise for this video. As always, you can start in either one of two places depending on whether or not you saved your work before. Here I am at the 6502 Assembly Language Course Files page, and you can see that we now have a new link. The page looks to see if you saved your work for a previous exercise and offers this link. So we'll click on that. And now we're looking at our source code, and we're going to look at ex4.asm and check out the task we have to accomplish. So we're going to add two numbers together, and the first number is in bits 5 through 7. That is the upper 3 bits of param 0, and the second number is in bits 4 through 6 of param 1. So we want to extract those two numbers, add them together, store the result in output 0. Now I'm not going to make you watch me type that solution, which I've done beforehand. And so if you want to have a try at it yourself, now would be the time. So if you want to pause me and have a go at that, that's great. There are links to these pages in the description. So welcome back. Let's click See Solution. And so let's have a look at what we're doing. So in the first part of the solution, we're loading param 0 into the accumulator and then rotating it left through the carry, isolating the bits with an AND instruction, and saving that in output 0. Now we're not really done yet, but output 0 was a convenient place to store it for reasons that you'll see in a moment. Now we'll look at param 1, and we're going to shift that the other way using logical shift right, and we're going to do 4 shift instructions to get those bits in the appropriate place in the lower order bits of the accumulator, and then we're going to use an AND instruction to isolate the bits and make sure there are no other bits set to 1 that would mess up our add. Now since the 6502 does not have an add without carry, its only add instruction is add with carry, we're going to clear the carry flag beforehand. Then we'll perform an add with carry on output 0. Okay, so we store the first operand in output 0, and now we're adding the second operand to it. And finally, we're going to store the result back in output 0 and declare to the test framework that this exercise is implemented. Okay, so let's go run it. First of all, you can see that the test framework liked our solution because we have another green light here. But I'm going to put a breakpoint in EX4 so we can step through it. I'm going to click on the CPU tab, and I'm going to zoom in just a little bit. Okay, so we're going to step through the load A. Now we have this value in the accumulator, and you can see the high order bits have the value 011. That's a decimal 3. So now we're going to rotate that 011 down to the low order bits, going left through the carry. So let's do some stepping. You can see over here the value getting shifted, and the carry flag will be changing. Shifting. Okay, now we have the bits in the low order, or the value in the low order bits of the accumulator. And you see we do have this extraneous 1 here that we'll get rid of with the AND instruction. Okay, now we've got rid of all the extraneous bits, and we're going to store that temporarily in output 0, and then look at param 1. So here are bits 4 through 6, and they have the value 100 or decimal 4 in those bits. So again, we want to rotate these or shift them to the low order bits, mask them off, and perform a add. Okay, see the 100 in the lower order bits. Now we're going to do the AND operation just in case there's any extraneous bits on. And then we're going to clear the carry and add output 0 as we've discussed before. Okay, so our result ended up being 111 or 7 decimal. So we're storing that in the output area, output variable, and off we go. Okay, so I hope that this video has been valuable to you and that you understand shifts and rotates a bit more. And I appreciate your watching, I really do. And if you find value in what I'm doing here, please click like and subscribe. Thanks very much and have a great day.